guys, I'm here to present a new lesson to some of you, for some of you maybe a review, on something called Pythagoras Theorem. Now, before I dive into the theorem and the concept with the material, I want to share a story with you about Pythagoras himself, because he is a person that we owe a great deal of gratitude to. So he was born about 570 BCE in a place called Samos. But when he was about 50 years old, okay, 50, so a lot of time went by in his life, and he moved to southern Italy, in Naples. So there he formed a religion in which he and his followers contemplated the divine and sought the purest truth to be found in nature, in the universe. So they're exploring, and they really thought everything in the universe could be explained mathematically, even things in nature. So he and his followers did a lot of work in music. They did a lot with thinking about how music and harmony could be explained mathematically. But besides that, they were also extremely interested in triangles, especially that Egyptian rope triangle we talked about, or you have heard about many times in the Egyptian rope stretcher story. So they wanted to figure out exactly how that pattern worked, or that relationship worked. So they did a lot of work with right triangles specifically. And if you remember the rope stretcher story, there was a rope that was knotted at 3 knots, 4 knots, and then 5 knots. And when that was laid out, it was a right triangle. Well, Pythagoras and his followers discovered that there are only particular relationships that make that right triangle. And when I say that, I mean particular relationships between the 3 sides that make up the triangle. So the 3, 4, 5 relationship was one of those, okay? But not every set of measured lengths make a right triangle. We know that from all of our experience working with them. So to figure out which relationships did work, they just explored and explored and explored. And eventually they figured out which lengths do make a right triangle. And now we call those Pythagorean triples. Any set of measurements of those 3 sides that make a right triangle. Okay, so basically, that wasn't the only thing they were exploring. Pythagoras also explored other patterns that emerged within this right triangle. And today's lesson is going to be exploring his theorem and what he discovered about them for ourselves. Okay, hi guys. So here I have a plate, which is material I took from the classroom, and it's used to help demonstrate one of Pythagoras's ideas, or his theorems. And he theorized that if you have a right triangle and you built squares off of both of the legs of the triangle, as well as off of the hypotenuse of the triangle, that the sum of the squares built off of the legs would be equal to the square built off of the hypotenuse. Now, when I say that, obviously we're talking in terms of the area that fills in the square. So before we dive into that, let's just take a look at our right triangle here, and I'll position it so you can see the right angle very obviously. All right, so we have the right angle here, okay, and the side directly across from that right angle is what's called the hypotenuse, in case you forgot. The other 2 sides are referred to as the legs. Okay, so let's take a look. On this square built off of this smallest leg, we have basically a 9 square, right? We have 3 taken 3 times. 1, 2, 3. 3 times 3 equals 9. So we have an area of 9 for this square. And for the larger square built off of the longer leg, we have the square of 1, 2, 3, 4. 4 taken 4 times is 16, right? Now, if you were actually here, I'd let you count each one of those if you needed to. I'm not going to do that now, but I think visually you can tell that there are 16, okay? So if you think about this, we have 9 plus 16. So I'm going to let you add that up either on paper or in your mind. If you need to, you can pause the video. Okay. After you pause it and you have figured it out, play the video again. 16 plus 9 should equal 25. Well, our largest square built off of the hypotenuse happens to be a square of 1, 2, 3, 4, 5. We know 5 taken 5 times is indeed equal to 25. So for this right triangle, Pythagoras' theorem works. And let's take a look at this triangle. Okay, you may not be able to tell very clearly on the camera, okay, but let's see if we have 2 sides that are equal in length. Obviously, this one is not equal to any of them. If we hold it here and then switch it to see if the other side matches in length, it clearly does not, right? And you could have figured that out by the size of the squares that we were talking about as well. So for a right triangle whose sides are all different lengths, what do we call that? A right triangle whose sides are all different lengths. Think about it for a moment. We call that a right-angled scalene triangle. Scalene means all 3 sides are different lengths. Okay? So Pythagoras' theorem does work for right-angled scalene triangles. I wonder, does it work for other right-angled triangles? There's another plate we have in class, and some of you may remember it was an isosceles right-angled triangle. Perhaps some of you could comment on whether Pythagoras' theorem worked for that one. More lessons to come on this theorem. More of them, obviously you can't do a lot of follow-up because you don't have this material, and even if you did have the material, there's not a whole lot more to do, but I do have more lessons that will lend themselves well to follow-up work, and I will update or upload that material for you to print out at home and be able to do off of your computer, like away from your computer as well. So look forward to that. But for now, I hope you enjoyed the lesson and have a wonderful day.